Now the goal is to rewrite the integrand using trigonometric substitutions. We observe that there is an expression that involves the binomial x squared minus a squared, so we start with the right triangle. Since the expression is x squared minus 9, the hypotenuse must be x and one of the sides is 3. The missing side is therefore the square root of x squared minus 3 squared. Using the right triangle, we obtain cosine of theta equals 3 over x, and so x is 3 secant theta. We're going to rewrite each expression in the integrand in terms of theta, with x be 3 secant theta. And so x squared is 9 secant squared theta. Thus we're going to replace x squared with 9 secant squared theta. The expression x squared minus 9 is therefore x squared is 9 secant squared theta, and we simplify it to 9 times the quantity secant squared theta minus 1, but secant squared theta minus 1 is tangent squared theta. With the proper restriction on the domain of theta, the square root of x squared minus 9 is the square root of 9 tangent squared theta, or 3 tangent theta. We have a substitution for x squared, which is 9 secant squared theta. We have the substitution for the square root of x squared minus 9, which is 3 tangent theta. We still need dx. But x is 3 secant theta, then dx d theta is 3. The derivative of secant theta is secant theta tangent theta. The difference for dx is 3 secant theta tangent theta d theta. We now have trigonometric expression for all of the factors in the integrand. The integral 1 over x squared, the square root of x squared minus 9 dx is now the integral of 1 over x squared is 9 secant squared theta. The square root of x squared minus 9 is 3 tangent theta, and dx is 3 secant theta tangent theta d theta. Cancel out secant theta and tangent theta. To simplify this, we have 1 over 9, the integral of 1 over secant theta d theta. But 1 over secant is cosine, and so we have the integral of 1 over 9 cosine theta, which is 1 over 9 sine theta plus c. Again, this is not the final answer. We still have to rewrite this expression in terms of x, but using the right triangle, sine of theta is opposites over hypotenuse, and so the answer is 1 over 9, the square root of x squared minus 9 over x plus c.